Okay, here's two different integrals. So here you've got something squared, the integral of 3x plus 2 over x all squared with respect to x. And on the right you've got the integral of x squared minus 2 over root x. So what we're going to do, we're going to simplify these, or expand in this case, in here, make this into two separate fractions and see where we can go from there before we actually use things we know about the functions to integrate. So I'm going to square this. So this is a perfect square. So this is the same as the integral of, well, 3x, this is going to be a squared plus b squared plus 2ab. So a squared is 3x squared, which is 9x squared, plus b squared, well, it's 2 over x squared, which is 4 over x squared, plus 2ab, so that would be 2 times 3x times 2 over x. Like that, tidy it up in a minute, dx, so it's the integral of all of that with respect to x. So that is the integral of 9x squared plus 4x to the minus 2 plus, and then this actually, the nastiest looking part will actually end up looking the best, so because the 3x and the 2 over x, the x's cancel out, you've just got 2 times 3 is 6, times 2 is 12, so plus 12. So it's the integral of all of that with respect to x, and I've again not left much room for the bracket. So then you can proceed to use what you know about polynomials, so equals, so this is going to be 9, leave the 9 as a constant, x cubed over 3, so 9x cubed over 3, we'll tidy it up later, plus, leave the 4, raise the power by 1, so minus 2 will go to minus 1, so x to the minus 1 over minus 1, tidy it up in a minute, plus, well, 12 integrates to 12x, plus the constant of integration. So then, well, 9 over 3 is just 3, so that will be equals 3x cubed. 4 divided by minus 1 is minus 4, x to the power minus 1 is 1 over x, so minus 4 over x, plus 12x plus c. What we're going to do on the right, we're going to treat this as two separate fractions, so we're going to split it up. So equals the integral of x squared over root x dx minus the integral of 2 over root x dx, just like that. So, well, this is x squared over x to the power half. So I'm going to write this down. So equals the integral of x squared minus x to the half dx minus, well, I can pull the 2 out as a constant, so minus 2 times the integral of an x, anything in the denominator is negative, so x to the minus a half dx. So using your basic index laws, 2 minus a half is 1.5, which is 3 over 2. So this is the integral of x to the 3 over 2 dx minus 2 times the integral of x to the minus a half dx. Now you've got it in a position where you can integrate quite nicely. So use your polynomial rules. X to the 3 over 2, you add 1 to the power, so that would be 5 over 2, so x to the 5 over 2 divided by 5 over 2, so dividing by 5 over 2 is the same as timesing by 2 over 5, and then minus 2 times, well, x to the minus a half, and then you're adding 1 to that, so that would be x to the half. Dividing by a half is the same as timesing by 2 over 1, so minus 2 times that plus the constant of integration. So you end up with equals 2x to the 5 over 2 over 5, so 2 over 5x to the 5 over 2, minus 4x to the half plus c. Now, just because this 5 over 2 isn't particularly nice to simplify, I'm just going to leave it in this index form. It's absolutely fine. I suppose you could have a mix of kind of a square root and an indice, but I like to be consistent one way or the other. And because I'm not going to simplify this, or I'm not going to rewrite this, I'm not going to do it with that either.